What is up, ladies and gentlemen? In this video I will be covering Chapter 16, Section 13, Robotic Output Devices. Just a little bit of trivia. This here is the last video, the last section in the last chapter, so let's finish this out, huh? Robotic Arms. This is the most common robotic output device. A variety of robotic arms are available for use, ranging from very simple lifting devices to advanced devices with many joints, multiple degrees of freedom, and as much dexterity as a human arm. In theory, anyway. Arms are powered using relay circuits and motors. They are, as I said earlier, they are the most common output device. This is due to the range of tasks they can complete, from lifting and moving objects, even down to delicate tasks like welding and painting. Obviously, painting isn't like a huge deal. I mean, there have been some robots developed that are able to supposedly produce art, like Ractor, who writes poems, but I'm not really inclined to call them true artists as of yet. In these two pictures, I have just some standard shots of robotic arms, which they're most commonly used in industry, especially in the auto industry, which is based along an assembly line model, and robotic arms that can complete the same task over and over again without fail, without tiring, are definitely a very useful asset. In this, I want to cover, in these two photos, kind of arms that are useful for prosthetics may be developed as well. This man here is a double amputee, and he's using a robotic arm to help him perform everyday tasks. And on the right, there's a pretty standard looking imitation of a human arm. They can have specific tools permanently attached to them, or they may use a variety of clamps and fingers to grasp different objects. However, this usually is a more difficult process because the clamps need to be fitted with pressure systems in order to ensure that they grip delicate items without damaging them. Robotic fingers operate in a similar way, albeit more sensitively, offering great flexibility when grasping items. As I covered in my earlier video, with pressure sensors, such as a robot who picks up a baby or works in a hospital, it would definitely not be good for them to accidentally crush one of their charges. Haptic Control. If a robot is under remote human control, haptic technology is commonly used to give the operator feedback to indicate the state of the robot, such as vibrations or guiding forces. For example, a vibration may be felt if the robot comes too close or collides with an obstacle. This is further reflected in the Da Vinci surgical robot, which uses this technique to resist the surgeon's commands when they stray too far from a predetermined area of the body. So obviously, they can't slip and then all of a sudden the scalpel goes up and slices the person's jugular, because that would be bad. This is just a photo of what haptic control might look like at human-controlled robotic arm. Mimics the actions completed by the human hand enclosed in the glove-like device. Other output devices. Lights, sirens, and speakers are often used to alert workers to the presence of heavy, dangerous machinery in places where humans and robots work side by side. This helps to avoid potential accidents and fatalities, although it is not always successful. Movement. To move around environments, many robots use wheels or tracks. Legs can also be used, although moving efficiently on two legs is a difficult task for today's robots. I'll be covering more on that later. One of these problems lies in uneven surfaces, such as stairs or inclines, which are very difficult to get up. And these are just some standard pictures of all the systems I just mentioned. On the top right, there's a robot which is designed to move using legs, although this is extremely difficult without a human sense of balance or kind of sense of kinetic feasibility. On the top left, there's a robot which uses tracks. I believe it is a bomb defusing or kind of like scouting robot used by police and military. And the tracks are often more advantageous on uneven terrain because they can move over rocks and stuff. That's the reason why they're also used on search and rescue robots. On the bottom is just a robot with wheels. They can move faster than tracks, but they're also not as good on uneven surfaces. These are my references, and thanks for watching.